Okay, so actually this elementary I also already inside of my YouTube. Okay, if you rajin, you can find out this video. Okay, already uploaded in the YouTube. Okay, so let's look at the elementary I/O introductions. Okay, so elementary I/O similar to what you will learn in the SKE 1223, which is a digital electronics. Okay, you have a input output. Okay, so elementary I/O is a two-state peripheral device which allowing two-state condition. Okay, because it is a bistable or two-state means that it has only two outputs. Okay, either is on or off ataupun it will produce output 1 or output 0. Okay, for example, here you have a bulb. Okay, the bulb can be only either light on or turn off. So in AVR, okay, it can involve more than one bit at the time. Contohnya, binary code decimal. Okay, which is this BCD here. Okay, you are going to use the 7 display. Okay, so requirement, bit signal can be written out to output device under program control, and bit signal can be read from the input device under the program control. So by using the program control, you can read and you can send out the value to your input and output. Okay, for the device required, okay, latches is used as the output, while tri-state buffer is used as the input. This is how you're going to expand your input output port lah. Okay, if you doesn't have if you what we call here, if your input output port not enough, so you can expand your input output port by using the latches and buffers. Okay, no need to buy a new chip with a lot of input output port. By using latches and buffer, you can increase the number of your input output port. Okay, so example of output device such as a LED, this is the common output device. You have a LEDs, you have a bulbs, okay, and then you have the seven display. So this is the common output that you will going to use inside of this course. Okay, for the input device, we have a push button. Okay, switches ni memang selalu akan digunakan lah. Alright, and then you have a proximity switch, rotary BCD coder, and then you maybe have a deep inline switch and all those things. Okay. Yes, so let's look at the first elementary I/O that you're going to learn. Okay, the first one is LED lah. Benda biasa. This one is very basics lah. Okay, you already learned. Okay, in the digital electronic as well. Okay, so LED, so blah blah blah. So LED has two terminals here, which is anode terminal and cathode terminal. So how to identify which one is positive, which one is negative by looking at this terminal. The longer one supposed to be a positive lah, positive terminal, while the shorter one this belong to negative terminal. Okay, and then after that you need to see this flat here. Kalau ada flat, this belong to cathode, and then the what we call the flag inside of this LEDs. Okay, and then macam biasalah. So this LED is easily damaged by heat. So, okay, so make sure that you not directly connected the LED to your power source. If not, the LED will get burned. Okay, will burn, terbakar, and you can use the LED anymore. So what you're going to do is you need to put a resistor in order to limit the current that will flow to your LEDs. Okay, so how to what we call here, to put the resistor. Okay. Okay, so this is how you're going to put the resistor. Okay, so this is your VCC. Okay, and then make sure that the terminal is correct lah. Okay, this is a symbol LED, and this one is positive, and this one is negative. Positive must connected to the VCC and connected to your resistor in order to limit the current that go through to your LEDs, so that you can protect your LED from getting burned. And after that, you connect it to ground. Then the LED will turn on. Okay, so ideally for the 5 volt power supply, we use a 300 30 ohm resistor value. Okay, so this is for the LEDs. Okay, so how to turn on LED if you're connected to what we call here to your micro P or microprocessor. Okay, so first, what you're going to do is you need to identify lah. What type of common configuration that you are going to use? Is it a common anode or common cathode? Okay, for the common anode, ingat lagi tak common anode? Which terminal connected to your ground? Which terminal will connected to your micro P? Okay, for the common anode. So common anode. Whatever for the common anode. Okay, so for the common anode, all the anode, which is all the positive terminal, okay, will connected to VCC. Okay, so this is your LED. All the positive terminal will connected to your VCC, and the rest, okay, the negative terminal will connected to your output pin or to your port. Okay, so this is your port. You connected to your port to your micro P. So in order to turn this LED on, okay, so you need to give your port output 0 lah. Okay, why? Because VCC is high, logic high. Okay, the current only flow if there is a from high to low. Okay, from 1 to 0. When the current flow from 1 to 0, what happens is your LED will turn on. If you give a logic high to your output, okay, to your port B, so what happens? The LED will turn off. Okay, something like this. Okay, this is positive 5 connected to your positive LED, and then this negative terminal connected to your output pin. If you give 1 to your output pin, what happens is this is high, this is high, so current cannot flow because both are high. So what happens? There are no lights emit from your LED. Okay, so to turn on, okay, so since this one is a 5 volt, so you need to give 0 lah dekat you punya output pin, okay, to your port. Okay, give 0. So what happens? Because this is a high, this low, then the current will flow from high to low. So next LED will turn on. Okay, so this is the what we call here the equation lah. Okay, by using the V equal to IR formula. So this is how you're going to connect the LED to your what we call here to your Atmega 32. Okay, let's say lah you're going to connect your LED to port B. Okay, since our port B here is we have a 8-bit ataupun we have a 8 pin for the port B. So all the LEDs for the port B is connected to the common, okay, common source lah. Either it's a positive of VCC or negative ground. Okay, and then since this one is because all the positive here connected to your VCC, so what happens is if you to turn the LED on here, because this one is a common anode, so to turn the LED on, so you need to give us 0. Okay, make sure that every time you pasang your LED, make sure that you put the resistor to limit the current. Okay, so the rest of this pin, which is for example lah kat sini, okay, VCC must connected to VCC, which is 5 volt. Pin 11 need to connected to ground. P31 also connected to ground. 30 go to your VCC, and pin 9 must go to your reset button. Okay, then your Atmega 32 will works. Okay, akan berfungsi. Okay, so this is another what we call here another circuit diagram. Okay, which is this one here. You see, this is a LED. This LED here also a common anode. Kenapa common anode? Because all the anode positive terminal here are connected to VCC. Okay, and then it masuk to your pin 40 to pin 33. So this one, if you refer back to your Atmega 32 pin out. So this one belong to port A. Okay, so in order to use the port A as an output port, so you need to initialize dulu lah your port A, make it as an output port, and then after that you connect to your LEDs. Okay, and then give 0, barulah LED kamu nyala. If you give 1, the LED will turn off. Okay, so now we are going to write a program to count up and show the result of the counting by displaying at 8 LEDs that are connected to port A. Okay, so what you're going to do is, if you have what we call here, okay, if you're going to answer question something like this, so I advise you to lukis dulu you punya circuit. Okay, you lukis dulu your Vega 32 chips. Okay, and then you do all the connection. Okay, how many input do you have? How many output do you have? And the input connected to what port? The output connected to what port? Okay, for example, this one here, you have 8 LEDs that are connected to port A. Okay, contoh lah, I put the port A here. Okay, doesn't matter lah, you want to put the port A dekat belah kiri pun tak kisah. Okay, this is for your reference only. Okay, the circuit is for your reference only. Okay, so make sure the label is correct lah. Okay, so this is my port A. Okay, and then I sambungkan my port A to my LEDs. Okay, so let's see something like this. Okay, so ada 8 bit semuanya. I have all 8 bits connected to the same common, which is this one here. I use a common ground, which is this is a common cathode. Okay, all the cathode negative terminal are connected to ground. Okay, so in order to turn on this LED, okay, so what happened here is I need to give 0 or 1 to turn on if I use the common cathode. What value that I should give to my LEDs in order to make it the LED turn on? Okay, so I need to give a 1 lah. Okay, so give 1, the LED will turn on, and if you give 0, the LED will turn off. Okay, so this is how you're going to what we call here to write in assembly language. Okay, so in this assembly language here, you see, okay, you need to initialize the stack pointer. Kenapa nak initialize your stack pointer? Because you are going to use the what is this? Subroutine. Okay, to call a delays. Okay, you have a subroutine called delays. Okay, to generate a delay. Okay, because you going to do the counting. Okay, so in order to our eyes see the sequence of the counting, so we need to put a delay in between the first counting and then the next second counting. If you not put delays here, what happen is kalau kamu tak put delay, so you cannot see the changes. Okay, from number 1 to number 2 because it's very fast. So in order for us to see the changing from the changing of the counting from 1 to 2, 3, 4, 5. So we put a certain delay. Okay, so in this case, okay, since we are going to use a subroutine delay, so that's why lah kat sini, okay, you are required, okay, must, okay, you are required to initialize this stack pointer. Okay, so this is a stack pointer initialization. Why? Because you are going to call a subroutine. Okay, kalau kamu tak pakai subroutine, then no need to initialize the stack pointer lah. Okay, and then, okay, when you initialize the stack pointer, the second one here, okay, next, what you're going to do is, okay, you initialize your input output port. Okay, so in this case here, only output port, so that's why lah, load I R20 OXFF and out DDRA R20. So you're going to set your port A here as a output port. Okay, and then you start the counter lah from 0 because you're going to count out. Okay, do a count out from 0 to 5. Okay, And then start the loop. Okay, so usually, okay, by right lah, for this thing here, okay, I put the increment down here. Okay, because if you put increment here, what happened is now your R20 is 0. If you put increment here, now it started with 1. Okay, so the 0 will never be displayed to your LED. Okay, the count 0 never displayed in your LED. So better we put the, okay, out port A R20, and then after that, barulah kita do the increment R20. Okay, and then you call the delays 1 second. Okay, why you call the delay 1 second? Because you're going to see the changes lah between from number 0 to count number 1 to count number 2 and until 255. Okay, and then use a jump lah. Okay, this one here jump to loop because we're going to do it continuously. It means that from 0 until 255, and then after 255, it will go back to 0. So this is how you're going to write in the assembly language. Okay, so now instead of using the assembly language, we are going to write in C programming. So how to do that? Okay, so in the C programming, first, what you're going to do is, okay, sama. Okay, so you need to initialize yang ni dulu. Okay, initialize your header file. Okay, so in this case here, we are going to include avr/io.h. This is the standard lah. Okay, every time you write down your program, make sure that you include this file here. Okay, the avr/io.h actually equivalent to m32.dev.inc in assembly language. Okay, so it is equivalent. Okay, avr/io.h is equivalent to m32.dev.inc in assembly language. And then we define our CPU speed. Okay, for this one here, you define your CPU speed so that your CPU speed is 1 megahertz. And then you're going to include the delay function. Okay, by using the util/delay.hash. So this is the delay function that already, or delay library that already available in C program. Okay, so you're going to use that. Okay, and then after you do you include the file, you define the variable that you're going to use. Okay, and then baru kita start with our main program. Okay, so this is the things that you're going to write lah. Okay. Okay, int main program. Okay, this is number 1, and this is number 2. Okay, so make sure that you started with int main void. Okay, to start your main program, followed by open curly bracket and close curly bracket. So all of your program will be written inside of this main program. Okay, semua program yang kamu nak tulis akan ditulis dalam inside of this main program. What about your function? If you're going to create a function, your function must be created outside your main program lah. Cannot put your what we call here your function that you're going to create. Contoh lah. For example, this one here, you're going to create a delay 1 second function. Okay, don't create inside here. Okay, if you're going to use a timer 0, so don't create your timer 0 time to generate 1 second delay inside of your main program. You need to create your function or subroutine outside of your main program. Okay, and then start with initialize your input output port. Okay, so you only have one output port, which is 8 LEDs connected to port A. So you know that port A become output port. So that's why you put DDRA equal to 0xFF. Okay, and then initialize lah. Okay, and then define your counter. Okay, so in this case here, this is an unsigned char counter. Okay, means that you're going to to declare or to define this counter variable here as a char 8-bit data, and it is an unsigned numbers. Okay, make sure that every time you use a variable, make sure that you declare the data type. Okay, kena declare every variable with the data type. Either it's a 8-bit number, 16-bit number, ataupun 32-bit number, and at the same time, either it's a signed number or unsigned numbers. Okay, and then after that, okay, you started lah your counter with 0. Okay, and while one, what this while one do? Siapa boleh tolong? What the while one do? Okay, what this loop do? While one means that you're going to do this loop forever. Okay, continuously. So that's why you put 1 dekat situ. While 1. Okay, so this is a continuous loop. Okay, port A equal to counter. Okay, so this one here, port A equal to counter, actually yang this one lah. Okay, yang ni tadi. Okay, out port A sama dengan R0 R0 ke? No, R20. Okay, so you send the value from R20 to your port A, which is port A sama dengan counter, and then counter equal to counter plus 1. So you increase your counter with, okay, so this is equivalent to increment R20 in assembly language. Okay, then after that, you call delays. Okay, so since this one here, we use the delay function, so just write down underscore delay underscore ms 1000 to generate 1 second delay. Sorry, 1 millisecond delay, not 1 second, 1 millisecond delay. Okay, and then this one will keep looping continuously until, okay, we started with 0, and then it keep counting until 255, and once reach 255, it will turn, okay, it will revert back to 0. Why 255? Because, okay, you already declare that your counter kat sini size dia ialah char, which is 8-bit wide. Okay, so that is for the LEDs. Okay, how to make the LED turn on. Okay, next we have the 7-segment display. Okay, so there are applications where you need to display a decimal digit using a 7-segment LED display. Okay, to display a decimal number, so we are going to use the 7-segment display. So the display could represent either the number of the time as a switch was pressed, ataupun you're going to do a timer. Okay, so digit 0 to 9 and hex AF to F can be displayed by giving the proper 7-segment code. Okay, so this is your 7-segment display. Inside of your 7-segment display, you have total of 8 LEDs actually. A, B, C, D, E, F, G, and satu lagi we call it as a H. Okay, for the decimal point. Okay, so to display number 0, for the 7-segment display, okay, it can be divided into 2 types. Okay, 2 common configuration. One is a common cathode and the other one is common anode. Sama juga dengan LEDs tadi. Okay, common cathode, you have a common cathode and common anode. Okay, for the common cathode, okay, you put 1, then the LED will turn on. For common anode, okay, you put 0, then the LED will turn on. Okay, so in this case here, okay, since you are going to display 0, okay, for the 0, So the LED that need to turn on is A, B, C, D, E, and F. G and H should be turned off. So that's why lah kat sini you see A, B, C, D, E, F got 1, while G and H you put 0. This is how to display 0. Okay, according to this, what we call here 7-segment LED. Okay, so make sure that this A, okay, make sure that A is your LSB and H is your MSB. Okay, to display number 1, so only B and C should turn on. Okay, B, C turn on while the rest turn off. Okay, I assume that all of you already know how to what we call here, to come out with this code here. Okay, this value, okay, depending on the number that you're going to display on your 7 display. Okay, so if you're going to use the common AND, so what happens is just invert je lah. Okay, to display number 0, so what number that you need to put is 1, 1, 0, 0, 0, 0, 0, and 0. So this is for the common AND. Okay, make sure that you need to identify lah what 7 segment that you're going to use, either it's a common cathode or common AND. Okay, based on this common here, then you can figure out the value that you're going to put to your LEDs, okay, to display the numbers, okay, or to display the certain characters. Okay, so as I mentioned, you have two type of common 7-7 display, common AND and common cathode. Okay, so this is how you're going to turn on. Okay, since this is a common, okay, all the cathode is connected to ground, so this is a common cathode. In order to turn on, make sure that you give 1, okay, to your output port. Okay, for this one here, all the positive here is connected to VCC. In order to turn on, you need to give 0 at your output port. Okay, so for examples here kat sini. Okay, we look at the example. Okay, the 7-segment display could be attached to AVR as follows. So this is your Atmega 32, and then this is your 7-segment display, and you connected this 7-segment display to your port B. Okay, so since, okay, first, by looking at this 7-segment display, you know that, okay, this 7-segment display is use a common cathode. Okay, because all the cathode are connected to ground. So when common cathode, so you know, mana common cathode, when common cathode you give 1, the LED will turn on. You give 0, it will turn off. Okay, so if 0B00111111 was output from your port B, okay, so you need to find out what are the characters that will be displayed to your 7 segment. Okay, so first, okay, you need to know lah. Okay, so this is your PB0. Your PB0 connects to your A. So this is your A. Okay, and then this is your H. Okay, so since this is your A is 1, so this one is turned on. B also turned on. C on. D on. E turn on. F turn on. Why? Because A to F you give 1, while G and this decimal point here you give 0. So that's why it turn off. So the number that will be displayed after you put this value to your output port, so it will display value 0. Okay, so next, okay, so you are going to write a 7-segment display is connected to your port C. So write a code that display 1 on the 7 7 display. So first, what you're going to do is we need to identify lah. This 7 display, is it a common ended or common gated? Okay, so in this case, so let's lah, this one is common gated. Okay, so common gated, to turn on, give 1. Off, you give 0. Okay, you're going to display 1. Okay, so to display 1, so LED B and C should be turned on lah. So the value that you need to send out to your port C would be, okay, so A, B, C, D, E, F, G, H. Okay, C and B turn on, so this will get 1, the rest will get 0. So this is the value that you're going to send to your port C. Okay, so how to do that? Okay, so you do a programming lah. Okay, first include this file here, include avr/io.h. Okay, this is a must lah. This is a must. Yang ni mesti. And then start with your main program. Okay, int main void, open curly bracket and close curly bracket. Initialize your port C. Okay, since port C connected to a 7 segment display, so you know that port C become output port. So how to make the port C as output port? By giving DDRC, okay, by giving 1 to your DDRC. Since all the port C here, all the 8 bit from the port C connected to your 7 segment display, so that's why lah, DDRC equal to OXFF. Ataupun you can write down DDRC equal to 0B11111111 pun boleh, or you can simply write down DDRC equal to 255 pun boleh. Okay, you can choose either one. Okay, either one. Nak pakai hexadecimal, you're going to use the hexadecimal, or you're going to use a binary number. So this is in the binary number, or you're going to use in decimal representation. Mana-mana pun boleh. Okay, and then next, after you initialize your port as a output port, the port C as output port, then after that we send out this value to display number 1. Okay, so by write down port C. Okay, so port C. Okay, just simply write down port C sama dengan, okay, just write down port C sama dengan, okay, and then this value here. Okay, so this is a 00000010. You can hantar the binary number to your port C, ataupun you can change this one to hexadecimal. What is the hexadecimal? So this is a 06. So that's why port C equal to 0x06. Okay, if you don't want to use the what we call here hexadecimal representation, you can use a binary representation by writing down port C equal to 0B00000110. Okay, or you can simply change, okay, use the port C sama dengan what is the decimal value. Okay, tukarlah 06, tukar dalam decimal value, which is 6. Pun you will get the same output to your 7 segment display. Okay, next, another example. Okay, the similar with the one we did earlier. Okay, port. Okay, this one here, port C or port A? Port C. Okay, so please change this one to port C. Okay, a 7 segment is connected to your port C. Write a code that display number 3 on the 7 segments display. Okay, so again, okay, include this file. Start with your main program. Open curly bracket, close curly bracket. Okay, and then what you're going to do is initialize your input-output port. So in this case here, only one port you're going to use, which is a port C connected to 7 segment displays. So you initialize your port C become output port. So DDRC sama dengan OXFS. So automatically your port C become output port. now you're going to figure out what is the value that you're going to send to your port C so that your 7 segment display will display number 3. Okay, so assume that, okay, in this case here, I'm going to use a common, NAND. Let's say lah, my 7 segment display is a common NAND. Okay, so for the common NAND, you know that to turn on, you need to give 0. Betul tak? Okay, so now you're going to what we call this display number 3. So you need to find out lah what is the value that you need to send out to your port C. So A, B, C, D, E, F, G, and H. Okay, so this one here, A, B, C, D, E, F, G. Okay, A, B, C, D, and G will turn on. Okay, so A gives 0, B also 0, C 0, D 0, G 0, while the rest you put 1. This is only valid for the common NAND lah. Kalau common cathode, it will be inverted. Okay, so just write down port C equivalent to 0B10110000. This is in binary number. Okay, if you're going to use a hexa also can just write down port C sama dengan 0x. Okay, so this one here is 8421. So 11 is B 0. So it is equal valid. Okay, any question? Ada soalan tak? We have more examples in this module 10. Okay, we are already in module 10. Module 9 we dah habis. Now we are in module 10. Okay, so this one here. Okay, a switch is connected to pin P0 and a LED. And a LED to PB7. Okay, you have one switch, one LED. Write a program to get the status of the switch and display it at the LED. Okay, press switch LED off. Okay, so this is what we call here the circuits. Okay, switches. Okay, you have a switch connected to your PB0 while LED connected to PB7. So how to write the program? Okay, mula-mula what you going to do? Identify dulu lah. Okay, what type of switch that you're going to use? Is it an active low switch or active high switch? And what is a common configuration this LED use? Is it a common NAND or common cathode? Okay, in this example here, what type of switch that this example use? Siapa nak tolong? Common NAND ke common active high or active low? Okay, so when you press, what happen? It will produce output 0 or output 1. Okay, when you press the switch, by looking at this what we call here circuit. Okay, bila kamu press, okay, it will give 0. Okay, when you press this switch here, okay, it will give 0. Okay, when you release, it will give 1. So this one here belong active high atau active low? Siapa nak tolong? Saya pun tak ingat lah. Active high, active low. Is it active high or is it active low? Can you tell me? Okay, it is an active low. Why active low? Because when you press the switch, it will give output 0. So active low. Maksudnya bila kita tekan, we press, which is when it active, it produce 0. So this is an active low switch. Okay, so okay, so you know this one is active low. What about LED? Is a common and non-commutated. Okay, identify dulu. This is a positive, this is negative, negative connected to ground. So this one is common. Cathode. Okay, because all the cathodes are connected. The cathode is connected to ground. Okay, so to turn on, you need to give 1. Okay, so how to write down the program? Okay, so this is when you're going to write down the program. Okay, for what we call here in assembly language lah. Okay, so now we just keep the assembly language. We are going to focus on the C programming. Okay, the first thing what that you're going to do? What you're going to do? What you're going to write? Kita tulis apa dulu? Okay, include your avr/io.h file. Okay, so you include this file here. Okay, once you finish include this file, then you started with your main program. Okay, and then you see here, this is a PB0, this is PB7. Okay, so inside of your port B, you have a mix of input and output at the same time. Okay, so PB7, you know that this belong to out, and you have a PB0, this is you connected switch. So this is your input. Okay, so that's why lah, I put DDRB equal to 0B. Okay, in this case here, okay, every time I want to initialize my input output port, so okay, so better to write down if I have a mixed input and output at the same time. Okay, better for me to write in the binary representation. Okay, because I don't want to have a wrong value lah. Okay, so since PB0 is input, so I give 0 to PB0. PB7 output, I give 1 to my PB7. What about the rest? The rest, I just initialize this at a output port as well. Okay, so PB6 to PB1, I put 1. Okay, give 1 to this one. So what happened is only PB0 become your input, the rest as a output port. Okay, since this one here, okay, you have an input. So the next thing that you're going to use is, do this, you need to enable your pull-up resistor. Okay, so every time you have an input port, make sure that you enable the pull-up resistor. So how to enable the pull-up resistor? Okay, by simply write down something like this. Ataupun, okay, paling tidak pun, okay, you can simply write something like this. Okay, this is another way lah. Okay, if you don't want to write like this, you're going to write down something fancy like this to initialize your input output port. So you can put something like this lah. Okay, okay. So what this what you call it? Coding do, this instruction do. Okay, shift 1 to your DDRB pin number 7. Lepas tu and we put 1 to your DDRB pin number 0, but you invert and add it. Okay, by right it will become something like this lah. Okay, this is another way. This is the fancy way lah. Okay, to initialize your input output port. Okay, as for me, I rather use this one instead of make something fancy like this. Okay, but sometimes, okay, we the fancy thing is not the good thing lah. Okay, better we write the what we call the the easy way to initialize your input output port instead of using something like this. Okay, and then after you initialize your input output port, then what you're going to do is you need to enable your pull up resistor. Just write down port B equal to 0B 000000001. Okay, only PB0 get 1, the rest you put 0. So this one here, what happened? Enable pull up resistor at PB0. Okay, next. Okay, by using a while loop, kenapa using a while loop? Because I want to monitor the switches, okay, the status of this switch continuously. So that's why I use the while loop, okay, to continuously monitor switch. Okay, and then if by using the if else statement lah, the easy way to monitor is by using the if else statement. Okay, so if pin B equal to 0B11110, which is when you press your switch. Okay, you see here, when you press your switch, LED will turn off. So what happened is the LED, okay, you send out port B equal to 0. Else, okay, if your pin B here, okay, the value of your pin B here is 1, okay, when you not press the switch, the value is 1. So what happened? Port B equal to 0B1000. Salah ni. Okay, supposedly something like this. Okay, this is a wrong lah. Okay, I rather put something like this. Port B sama dengan 0B. Okay, LED turn on. Okay, the rest you off. Okay, this is when press switch LED off. Okay, sorry. Okay, so this one, okay, dia akan off. And then 000001. Why 1? Why I put 1 here? Can anyone tell me why I put 1 there? Instead of using the 0, okay, now I put 1 dekat situ. Why? Anyone? Can anyone tell, can somebody tell me why I put 1 to my port B? Okay, because if you see here, okay, this is how I'm going to enable my pull up resistor. If I put 0, okay, if I put something like this, port B equal to 0, what happens is my pull up resistor for PB0 already disabled, which is wrong lah. I don't want to disable my pull up resistor. My pull up resistor always need to be enabled at all time. Okay, so that's why instead of writing something like this, I change my port B instruction something like this. Port B equal to 0B00001. So that my pull up resistor at PB0 always enabled. Okay, else, okay, what happened when else? When the switch is not pressed, okay, it will produce output 1, it will produce input 1 lah dekat sini, pin B. So what happened is port B equal to 0B1, okay, so the LED will turn on. Okay, so this is your PB7 got 1, so LED on, and then 0000001. Okay, again. This one here, this is your PB0. Okay, your pull up resistor still enabled. Okay, if you put 0 at your PB0, then automatically you disable your pull up resistor. So any question? We stop here. Doctor, can we, okay, just asking, can we use the pin B equal to 0B0000000? Okay, if you put a 0000000, in that case also can. Boleh. Okay, Josh, you can use that. Okay, any other question, guys? Okay, if no question, then we stop here. Okay, and then please be prepared for your test 2. Okay, tonight. Okay, make sure that you're ready before 8 o'clock lah. Okay. Okay, make sure that your what we call here, your video